Hello my dear students, I warmly welcome you to CR Digital Classes. So now in this lecture, we are going to discussing another important problem from this unit, intermediate value theorem for derivatives. Okay, so we know very well mean value theorem, Rolle's theorem and Taylor's theorem so far. So now the last theorem of this unit is intermediate value theorem for derivatives. We already discussed intermediate value theorem in the second unit. Okay, so after that we have intermediate value, same theorem, intermediate value theorem for derivatives. In the next unit, that is unit 4, we have intermediate value theorem for integrals also. Okay, so in unit 2, so we discussed that intermediate value theorem, intermediate, just intermediate value theorem. Okay, so in unit 3, we are going to discussing that intermediate value theorem for derivatives. Derivatives is nothing but our unit name is differentiation. So that's why we are going to discussing that theorem, intermediate value theorem for derivatives. In unit 4, we have intermediate value theorem for integrals. Okay, why? Because the unit 4 name of the unit 4 is integration. So only one theorem only. So for the different concepts we are going to study that intermediate value theorem. For the differentiation we have the theorem, and the integrals also we have the theorem. Okay, so that is the types of the intermediate value theorems. So now in this part, so present unit 3 we are going to discussing about that the intermediate value theorem for derivatives. Observe the statement. Let small f be a differentiable function on open interval a comma b. Okay, whenever we are going to discussing about differentiable function, interval is open interval a comma b. If a less than x1 less than x2 less than b. Okay, so a and b and is an open interval. In that open interval there are 2 points, x1 and x2. Okay, so and if c lies between f dash of x1 and f dash of x2, for x1 x2 there is function values f of x1 and f of x2. ఆ ఫంక్షన్ వాల్యూస్ కి డెరివేటివ్ కూడా ఉంది, f dash of x1 and f dash of x2. ఆ టూ వాల్యూస్ మధ్యలో ఒక కాన్స్టెంట్ ఉంది c lies between f dash of x1 and f dash of x2. There exists small x in open interval x1 comma x2 such that we have to prove that f dash of x is equal to c. Okay, so that is the statement of the intermediate value theorem. So brief గా మనం అబ్జర్వ్ చేసుకుంటే ఏంటంటే f be a differentiable function on open interval a comma b. ఓకే, సో ఇక్కడ చూడండి, f be a differentiable function, f be a differentiable function on open interval a comma b. In this open interval a comma b there are 2 points, middle points, that means x1 comma x2 belongs to open interval a comma b. Now for at x1 we have one function value f of x1. Okay, for x2 we have one function value f of x2. For this f of x1 we have derivative f dash of x1. For this also we have derivative f dash of x2. Okay, so between these two, f dash of x1, f dash of x2, one constant is there, c. Okay, c belongs to f dash of x1 and f dash of x2. Okay, then there exists at least one element, small x belongs to a comma b. Okay, such that we have to prove that at that point x, derivative of f of x equal to constant, given constant c అని మనం ప్రూవ్ చేయాలి. Okay, so this is the total explanation, this is the total outlet of this theorem అన్నమాట. So therefore, so we'll start the proof. So see that proof, given that f is differentiable function on open interval a comma b, f dash of x exists on open interval a comma b, f dash of x exists on open interval a comma b. Therefore x1 comma x2 are lies between a and b. Okay, so that means you can write a less than x1 less than x2 less than b. Let c be any real number which lies between f dash of x1 and f dash of x2. Okay, c is a constant number. Mathematically it is written as f dash of x1 less than c less than f dash of x2. Now let g of x is equal to f of x minus cx. So okay, this is the function. So we are considering let g of x is equal to f of x minus cx be a function defined on open interval a comma b for x belongs to open interval a comma b. So then derivative of the function g dash of x is equal to f dash of x minus c. Okay, c into x derivation c kabatti. So that is taken as equation number 1. To prove that given condition f dash of x equal to c, okay, so we have to prove that this g dash of x value equal to 0 in equation number 1. We need to show that g dash of x equal to 0. That is our claim. Since f dash of x less than c less than f dash of x2, from this condition we are writing. So now I am subtracting minus c for that inequality or adding minus c on both sides. F dash of x1 minus c less than c minus c less than f dash of x2 minus c. Okay, so therefore again I am writing that value f dash of x1 minus c, this plus c minus c will get cancelled, 0 less than f dash of x2 minus c. And from equation number 1 we have g dash of x1 is equal to f dash of x1 minus c. From this equation only, equation 1 in terms of x is there. In terms of x1 we can write that value g dash of x1 equal to f dash of x1 minus c. Next to g dash of x2 is equal to f dash of x2 minus c. Okay, so ఇప్పుడు ఇక్కడ చూడండి మనకు f dash of x1 minus c is there, f dash of x2 minus c is there. Okay, so now in between those two values we can substitute g dash of x1 and g dash of x2. So therefore in between those two values we can substitute the value in here and here we can substitute this value g dash of x1 and g dash of x2. So if you substitute those values, then you will get clearly we can write g dash of x1 less than 0 less than g dash of x2 on open interval x1 comma x2. That means g dash of x1 less than 0 and g dash of x2 greater than 0, which shows that g of x assumes its minimum value on closed interval x1 comma x2. We discussed in the previous lecture, okay, from unit 2, where whenever you get a condition inequality in this format, then the given function f of x assumes its maximum or minimum values. So here we got only less than symbol, okay, only less than symbol, then it will assume its minimum. If it is less than or equal to symbol, it assumes minimum or maximum. Okay, so therefore minimum values on the closed interval x1 comma x2. At some point x0 belongs to the closed interval x1 comma x2. So therefore since g dash of x1 less than 0, from this condition only g dash of x1 less than 0. Okay, so substitute the formula for the g dash of x1. Limit y tends to x1, g of y minus g of x1 by y minus x1 less than 0. Okay, just we are substituting the formula by mean value theorem. So here this numerator value g of y minus g of x1, that is here g of y minus g of x1 value is non-negative. Non-negative is nothing but we can write greater than or is equal to 0. So therefore for any small y value near x1 and greater than x1, so we are saying that value is non-negative. How we can say that value non-negative? Means here y value near to x1, y value near to x1 and greater than x1, near to x1 and greater than to x1, then this total subtraction value is non-negative. In particular, there exists y1 belongs to open interval x1 comma x2 such that we can write, so y plus lo manam y1 substitute cheskunte g of y1 minus g of x1 less than 0. Okay, whenever you substitute that y1 belongs to x1 comma x2, so we can write that value is g of y1 minus g of x1 value less than 0. So from this condition, if you send that negative value to RHS, so g of y1 less than g of x1. From this condition, g of x does not take its minimum value. ఎందుకంటే మనము ఇక్కడ ఫంక్షన్ g of x అనేది అజ్యూమ్స్ ఇట్స్ మినిమం వాల్యూ అని చెప్తున్నాం. బట్ ఇక్కడ మనకేమొచ్చింది లెస్ దెన్ కండిషన్, అంటే g of x1 హ్యాస్ అ మాక్సిమం వాల్యూ అని చెప్తున్నాం. అటువైపు ఉంది కదా మనకు g of y1 లెస్ దెన్ g of x1. మనకేంటంటే ఇక్కడ సో దేర్ఫోర్ g of x డస్ నాట్ అజ్యూమ్స్ ఇట్స్ మినిమం వాల్యూ ఎట్ x1 అన్నమాట. So we have x naught not is equal to x1, where x naught belongs to closed interval x1 comma x2. So x naught belongs to closed interval x1 comma x2 అంటే either x naught is equal to x1 కన్నా ఈక్వల్ అవ్వాలి, లేదంటే x naught is equal to x2 కన్నా ఈక్వల్ అవ్వాలి. కానీ ఇక్కడ మనకి x1 దగ్గర g of x does not assume its minimum value కాబట్టి so we can say that x naught not is equal to x1. నెక్స్ట్ పాసిబిలిటీ ఏంటంటే సిమిలర్లీ ఇఫ్ దేర్ ఎగ్జిస్ట్ y2, ఇంతకుముందు ఏమో y1 తీసుకున్నాం కదా, సో నౌ y2 బిలాంగ్స్ టు x1 కామా x2 such that g of y2 minus g of x2 less than 0. So therefore g of y2 less than g of x2. Okay, so therefore by sending this value to this one, so clearly g of x also does not take its minimum value at x2. So therefore why? Because we are getting this value is increasing. So therefore, so again we have x naught not is equal to also x2. So clearly we have x naught not is equal to x1 and x naught not is equal to x2. Then definitely x naught exists in the open interval. Okay, so here x naught belongs to manam closed interval x1 comma x2 annam, but ఈ టూ కండిషన్స్ మనకు డస్ నాట్ ఎగ్జిస్ట్ అన్నాం. x naught not belongs to x1 comma x2. So definitely x naught belongs to open interval x1 comma x2. So therefore that is x naught belongs to open interval x1 comma x2. At this point x naught, g of x gets its minimum value. ఎప్పుడైతే అది మినిమం వాల్యూ గెట్స్ అని చెప్తున్నామో బై నౌన్ థీరం we can say that of g of x value దగ్గర, okay, g of x naught value దగ్గర the derivative is equal to 0. Okay, so therefore g dash of x naught is equal to 0. So therefore from equation number 1, whenever you get g dash of x naught value is equal to 0, so g dash of x naught is equal to f of x naught f dash of x naught minus c. Okay, so therefore this value is also equal to 0. So therefore 0 is equal to f dash of x naught minus c. So from this condition f dash of x naught equal to c for x naught belongs to open interval x1 comma x2. So therefore there exists at least one element. ఇదేంటంటే x naught. సో మనం in terms of x లో చెప్పాలనుకుంటే, so x belongs to, there exists at least one element small x belongs to x1 comma x2 such that we can say that f dash of x is equal to c. Okay, so this one is the proof of the given theorem. సో మనం రోల్స్ థీరం లో కూడా ఇది ఎక్స్ప్లెయిన్ చేస్తాం. whenever f is continuous on closed interval a comma b and f is differentiable on open interval a comma b, f of a is equal to f of b, then there exists at least one element small x belongs to open interval a comma b, f dash of x at that small x it has its minimum value 1 by Rolle's theorem only. So by applying that theorem also we can say that here g dash of x is equal to 0. Whenever g dash of x is equal to 0, then f dash of x value is equal to c. Okay, so this is the total explanation of that intermediate value theorem for derivatives. Okay, similarly we are also going to discussing intermediate value theorem for integrals also. మీకు ఇక్కడ మనం ఏమని డిస్కస్ చేస్తామంటే ఇంటర్మీడియట్ వాల్యూ థీరం ఫర్ ఇంటిగ్రల్స్ అంటే, సో f is continuous on closed interval a comma b, okay, and there exists at least one element small x belongs to closed interval a comma b such that f of x is equal to 1 by b minus a integral over a to b f dx. Okay, so this is the statement of the intermediate value theorem. Okay, so intermediate value theorem for integrals. So in this format we are also going to discussing this theorem is also. Okay, so f is continuous on closed interval a comma b, x belongs to closed interval a comma b, f of x is equal to 1 by b minus a integral a to b f dx. ఈ b minus a ని మీరు ఇటువైపు కూడా రాసుకోవచ్చు, b minus a into f of x అని కూడా రాస్తారు, is equal to integral a to b f of x dx అని కూడా రాస్తారు. దట్ ఈస్ అబౌట్ ఇంటిగ్రల్ థీరం. సో ఇక్కడ ఇదేంటంటే టోటల్ క్లోజ్డ్ ఇంటర్వెల్ మీద డిపెండ్ అవుతుంది. ఇంటర్మీడియట్ వాల్యూ థీరం ఫర్ ఇంటిగ్రల్స్. ఇంటర్మీడియట్ వాల్యూ థీరం ఫర్ డెరివేటివ్స్ అనేది మనకు వెన్ ఎవర్ వీఆర్ టాకింగ్ అబౌట్ డిఫరెన్షియేషన్ మనకంతా ఓపెన్ ఇంటర్వెల్. సో అంతా ఓపెన్ ఇంటర్వెల్ కాబట్టి మనం ఏం చెప్తామంటే ఇది కూడా x నాట్ డస్ నాట్ బిలాంగ్స్ టు x1, x నాట్ డస్ నాట్ బిలాంగ్స్ టు x2 అని ప్రూవ్ చేస్తాం. ఓకే, దేర్ ఫోర్ x నాట్ డస్ నాట్ బిలాంగ్స్ టు క్లోజ్డ్ ఇంటర్వెల్ x1 కామ x2 అని చెప్పేస్తాం. సో ఎప్పుడైతే x నాట్ అనేది does not belongs to closed interval x1 comma x2 aitado, then automatically it belongs to open interval x1 comma x2. So then by Rolle's theorem we get that g dash of x naught is equal to 0. So then whenever you get g dash of x naught is equal to 0, so then by using equation number 1, that value equal to 0, then our required condition f dash of x is equal to c will get. ఓకే, సో ఇలా మీరు ఒక్కొక్క థీరంని, రోల్స్ థీరంని, మీన్ వాల్యూ థీరంని, టేలర్ థీరంని, ఈ ఇంటర్మీడియట్ వాల్యూ థీరం ఫర్ డెరివేటివ్స్ ని మీరు ఒక్కొక్క దానికి ఒకటి అప్లై చేసుకుంటే మీకు కాన్సెప్ట్ అనేది ఈజీగా అర్థమైపోద్ది అనమాట. ఓకే, సో దిస్ ఇస్ ద టోటల్ ఎక్స్ప్లెనేషన్ ఆఫ్ దిస్ థీరం. I hope you understood this theorem very well. The next lecture we are coming with another topic. Okay, so make a perfect practice, prepare well. Until bye, thank you.